Howdy all, and welcome to my video. Up front, this is not a tutorial, but more of a walkthrough of my workflow on how I create CNC patterns from AI-generated images. Add-ons enabled, import-export STL format. I will be glossing over the first two steps of generating an AI image and then creating an AI-generated height map from it. If you're visiting this video, then you already have your own way of creating your own AI images. I have a Standard Diffusion XL locally installed on my computer using the Comfy UI interface. I am not very good at creating prompts, so my strategy is quantity in hopes of getting quality. So I will normally generate 10 to 20 images in hopes of getting one or two images I can work with. I have several AI height map generators installed on my computer, again using the Comfy UI interface. From my very limited experience, I've gotten the best results using the Marigold height map generator. Once I have a height map, I go into Blender and do my usual process of generating a mesh from the image. Delete the cube, add a plane, hit tab to enter edit mode, right click and select subdivision. On the subdivide panel, in the number of cuts box, enter 100 and hit enter. Hit tab to exit edit mode. In the Textures Properties tab, open the created height map image. Go to your Modifiers Properties tab, add Subdivision Surface Modifier. Add Displacement Modifier and change the mid-level to 0. Click the checkerboard Browse Texture to be linked button and select the height map texture. Change the subdivision modifier level until the detail is what you want. A quick way to apply multiple modifiers is to right-click and use the Convert to Mesh command. At this point, if you're happy with the model, you can export it as an STL, but typically it can be better. Let's do some post-processing of the model. First thing is there is some noise along the edges of the figure. For this, I normally add a smooth modifier to remove the noise and also to soften the edges. I change the factor to 1 and then play with the repeat number. I usually use 5 to 10, but have gone up to as much as 20 for a specific soft look in a pattern. At this point, the model is fairly dense, and depending on the power of your computer may really slow down the process. So I will reduce the density by using the Decimate modifier. I want to reduce the geometry as much as possible without removing too much detail. I normally use unsubdivide 2 iterations. This may take a few seconds depending on the model and your computer. Next is cleaning up the model. The strategy is to remove as much wasted height and retain the detail I want. The two main tools for this is polymodeling and digitally sculpting. With polymodeling, I hit tab to go into edit mode and change different levels of the model geometry. The different tools are X-ray mode to select sections of the model and also proportional editing. I can also delete parts of the model that I don't want or need, though in this case I will only be changing the levels. Next, I use digital sculpting to refine the model. The primary brushes I use are Draw Sharp, Clay, Inflate, Crease, Pinch, Grab, and Smooth. This may take a while as I refine the geometry to what I want. At some point, I will call it good enough and decide it is done and go back to object mode. At this point, if I am happy with a model, I can export it as an STL, or I can generate a new height map to try to emphasize the height differences in the model. To create a new material, go to the shader editor, click new, and then I use the following material node tree. Delete the principled BSDF node, add an input geometry node, add a converter separate XYZ node. Connect the geometry position to the XYZ vector input. Add a converter math node and duplicate it. Add a converter color ramp. Connect the Z data to the math node and change function to multiply. Connect math node to next math node and change function to logarithm. Connect math node to the color ramp. Change color ramp to B-spline. Connect the color ramp color output to the material output node. Unfortunately, there is no one value that is correct for all models using this technique. I will change the values of the math nodes and color ramp until I have the height map that looks right. Each model will be different, and I need to play with the values each time. Next is to set up the camera to render the image. I set rotation to 0 and the XY location to 0. I will change the resolution to a square. And the camera to orthographic. I change the orthographic scale until the camera view captures all the image. I will save the new height map as a 16-bit uncompressed PNG. I will bring back the new height map back into the scene and create a new model from it. I will compare this new model with the old model and may go back and tweak the values of the material nodes to change the different heights of the geometry. This may take several renders as I play with the different values. At some point I will call it good or good enough and export it as an STL for my CNC software. Here's a comparison of the original Marigold height map and the refined model next to it.